Okay, so it is time to start testing. Here's how this works. What we're going to do is we're going to have you come up one at a time. I'm going to take a look at your tower. I'm going to show you out of those 4 categories of things that we're looking at to grade them, what you got. For example, when I take a look at this, we have 20 points for dimensions. That is, did you make your tower the right size? Did you get it 8 inches tall? Close the Chromebook. Is it 2.5 inches wide between the 2 sides? Is it 2 inches for the 3rd dimension? Symmetry. Symmetry is when you designed your tower. Is the design itself symmetrical? That is, if we fold it in half in one of the other dimensions, will it be identical? Joints. The joints are how well you did cutting each of those pieces, putting them together, and gluing everything in place. Okay? I have 1, 2, 3, 4 people here that I have given the full amount of points to, which you know in Tech Ed doesn't happen often. So I will stop when we get there and we'll talk about that awesomeness. The 4th category, members, that is basically how flat does your tower sit? You'll remember when we put those 2 sides together that it's pretty difficult. If you have all 4 sides sitting nice and flat, your tower's going to hold a lot of weight. Every once in a while, they will rock back and forth. Okay? One, you're not going to get as many points as somebody else who had it done perfectly, but more importantly, we're going to need to figure out how to shim or push up that one side to give it some support, because 3 feet is not going to be as strong as all 4 on the floor. Okay? And the final category is weight held. Of course, I'm going to collect all the weight held right now. We're going to find a class average, and we're going to use that average, dividing it by 20, and figuring out the amount of points for the final category, which would translate into if one person in here has a tower that holds a lot more weight than everybody else, that person's going to get a better grade. Okay? All right, so without any further ado, the tower itself, we've talked about it before, but basically you have this piece that is threaded, and we'll go through the top of the tower, like so. We're going to put it into one of these 2 bolts down here. There are 2 places where you can put this thing in. Okay? This side, this is rated to 125 pounds. Okay? It is fairly accurate. On the other side, this side is rated to 250 pounds. It is not as accurate. Okay? Every once in a while, we will have a tower that goes up to 125 pounds. Okay? Don't feel all bad if yours doesn't. That's an astounding amount of weight. But if that happens, we're going to stop and let it sit for a couple seconds at that weight, and then I will back it off. And after everybody else is done testing their towers, I'm going to test it again on this side that's rated for 250 pounds, and it will go. About half the time we have the towers get back up to their original weight held, and sometimes exceed. Okay? All right, so that's the story. Let's see. Lanai, you ready?
No.
Good, come on up. Okay, kiddo. I know. It's best to go first. Dimensions, symmetry, joints, and members. Okay? All right, let's wash it. Any luck? Yeah, good. Okay, that's looking pretty good. I'm going to turn this thing on. I'm going to zero it out. We're going to put on our little blast shield here. We'll explode parts that way. All right, guys.
Do you have tape?
Now, when we're doing our testing, it's important to think about engineering a little bit. The idea of engineering is we come up with a solution to a problem. We engineer what we think is our best solution and build it. And then we test the thing that we built, which is where we're at. In a perfect world, we would have all kinds of high-speed cameras taking a look at different angles to see exactly what broke first. We are in middle school, so we don't do that. But as you're testing your tower, sometimes you'll be able to see things bend and contort and move around. You can see those stresses. Literally, you can see things moving. Okay? I want you to pay attention to that. Now, while we don't have time to go back and build another Balsa tower again, I do want you thinking about, well, what if? What if we could? What would I do differently? Did my idea of having these things bracing on this side work, or should I try something else? Do you remember when we did our bridge builder? How many of you had a bridge that held, a truck and costs less than $300,000. A bunch. Good. Okay. So when we're doing things in a computer environment like that, this is a good example of computer modeling and why it's effective. We can't take 3 or 4 days to build another tower to test our idea. But on a computer, we can press one button after making some changes and go back and try it again. Okay? So, let's squash it. What you're going to do when you come up here is read off these little numbers, and I'll let you know if there's something exciting happening up here. And without any further ado, we're on our way. There's 0. There's 0.4. There's 10. Read them off.
16, 21, 25, 27, 33, 38.
Good. There's the 40 pounds that you need for the full 20 points.
48, 50, 54.
There's 60. Come on.
68.
There's 70. Oh my God! 75 pounds. Give her a hand. 75 pounds. Okay. So what weighs 75 pounds?
Victoria. Yeah, Victoria.
Yeah. How many of you have cats?
I do.
Yeah? So when you have cats, you have to pick up a big thing of litter box. You know the big one?
Yeah.
That's about 40, 45 pounds. Picking one of those up. Which means you could pick up that huge thing and put it on top of a nice tower, and it would have been like, what else you got? And I think that's pretty impressive. Good job. All right, Mike, you can kill it.